Let's have a look at activity 2. It's on page 214. Activity 2, time series. Time series is a common form of line graph, in which time is represented on the horizontal axis. Now that's the horizontal axis. That's time. Horizontal axis. Horizontal axis. Horizontal axis. That's time. So as the time increases, we head in that direction there. Okay. And some other variable on the vertical axis. Now this is the vertical axis. It's often called the y-axis, the vertical axis. All right. Now they don't have anything listed here because it depends on the situation. All right. Depends on the situation. So you have to think about that when you get to question 2. But at the moment in question 1, what we need to do is to match these pictures with these time series line graphs. Let's look at the first one. We'll look at that picture and try to match it to these graphs. You pulled the plug in a bathtub full of water. Well, when you take the plug out, when you pull the plug, the water flows out through the hole at the bottom of the bath. So as the water comes out and time goes on, let's say that's 1 minute, 2 minutes, 3 minutes, 4 minutes, which line graph would represent what's happening in that situation? Now you've got to think about what you're actually talking about, and that goes on the vertical axis or the y-axis. We've got to think about what we're actually measuring. All right, so let's have a think about that. So think about that, try to match that with those 4, one of those 4. All right, so you've done a little bit of thinking there. Well, how about if we think about the y-axis or the vertical axis representing the level of the water level in the bath? If that was the case, as time increases, is the water level going up? No. No, the water level is going down. So maybe C could match that one, because as time increases, the amount of water in the bath is decreasing, is getting less. Now it's a straight line. This is a straight line, that's a straight line, that's a straight line. This is a bit of a curved line, but it's a straight line because the hole in the bottom of the bath is a size, and the water that rushes through the hole doesn't change. The same amount of water is leaving the bath as time proceeds onwards. All right, so it looks like number 1 is this one. As time goes along that way, the water level drops. So we would consider on the vertical axis the water level. Why don't we look at this picture? I'm going to jump that one for a minute. We're going to look at this picture, the third picture. Now, why don't you think about it? It says walking home from school at a constant pace. A constant pace means at the same speed. You're not changing your speed. Now, that information is telling us it will be a straight line. So it'll be one of the straight line ones left, walking home from school at a constant pace. Why don't you stop the video and think about it, or pause the video and think about it, and then I'll come back. All right, so walking home from school at a constant pace, we know it's going to be a straight line because it says constant pace. We've got time along here, so they've all got time. If we're walking home from school, could that be possible? Can you think of something we could put on the vertical axis to reflect that situation? It's a bit difficult with that line, isn't it? What about this line? Let's say we chose this one. What do you think might be on the vertical axis as time increases and you're walking home from school at a constant pace? What could be along here? Did any of you think of maybe the distance from the school? Because as time increases, the distance from the school is increasing. So the vertical axis, or the y-axis, could be the distance from school here. Let's have a look at this picture now. Sitting still for a period of time. Sitting still means not moving for a period of time. So try to match that with the remaining ones. That one's left and this one is left. So which one of those 2 do you think might be this situation? And then if you choose this one, for example, what would be the vertical axis? What would that be? If you choose this one, what would be the vertical axis? Think about that and pause it, and we'll come back in a minute. Okay, so you thought about this one, sitting still for a period of time. Well, it's hard to think of a situation that whether that would match. But what about this one here? Something is not changing. That's showing as time increases, something, whatever we just consider for the y-axis, that's not changing. It's just going straight. The value would be the same on the y-axis, the vertical axis. So how about maybe the heart rate? Their heart rate, that wouldn't change. Let's say they do it 60 beats per minute, their heart is going. If they're sitting still, that's going to stay the same. It's not going to increase like when you do activity. Okay, it's just going to stay the same if you're sitting still. A heart rate might be possible down the side here, heart rate. They're sitting still. Okay, and the last one is this one, a train accelerating out of the station. The key word here is accelerating. It's not constant. Accelerating means you're getting faster and faster. When you're getting faster and faster, as we saw over here, constant pace meant it was a straight line. But accelerating means it's not going to be a straight line because the speed is increasing and increasing. And this shape here would be for that one. So in the end, we choose this picture here would be that one, B. This one here, walking home from school at a constant pace, we chose this one. Then that's distance from school is increasing. Sitting still for a period of time, thought of that one there because maybe a heart rate, just be constant there. And then the first one, pulled the plug in a bathtub full of water. That would be the level of the water or the amount of water is going down. Okay, that's how we talk about activity 2, question 1. Now, what about question 2? Given the time series graph below, think about what story might explain it. Time is along the horizontal axis, but you need to decide the units, second, hour. So that could be in seconds, or it might be in minutes, it might be in hours, it might be in months, years. You also need to decide the measure and scale of the vertical axis. So what is this? Okay, what is that? We saw when we talked about the bath, we said level of water, sitting still for a time, heart rate, walking home from school, distance from school. Okay, train accelerating out of the station. There was this one. So what would you put along down here? Now, if you're not sure how to do question 2 yet, you need to write a story, maybe five lines. 5 or 6 lines. If you're not sure, why don't you go on to step number 2 of this lesson, have a look at the video, and then come back to this one. All right, and then see if you can make a story. But when you write the story, you've got to think about what that might measure and what are the units of it. All right, good luck with that, guys. Okay, there's just one thing I'd like to add, and that was this story here, a train accelerating out of the station. We didn't really actually say what that vertical axis would reflect, but again, it could be the distance from the station, because as the train is accelerating, it's slowly moving out of the station, then it's getting faster and faster and faster, so it's moving away from the station faster. That's why that's going up on that angle. It's not a straight line. Okay.